Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 14 in our incredible tutorial series where you are learning artificial intelligence on the Jetson Xavier NX. I will need you to pour yourself a nice enormous mug of iced coffee. That would be strong black coffee poured over ice. No sugar, no sweeteners, none needed. And you can also pour yourself a nice cup of hot coffee as a backup, because we're going to be learning lots of cool stuff today. I will also need you to get out your Jetson Xavier NX gear. And as you're getting out your gear, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to learn today. This is a follow-on lesson from lesson number 13. And what we're going to do today is we're going to learn how to identify and recognize faces using the Jetson Xavier NX. Now in lesson number 13, we installed the libraries, the face recognition library and the Dlib library that will allow us to do the facial recognition. If you have not done lesson number 13, you need to hop back over there and do it, because today's stuff isn't going to work if you haven't already installed those libraries. Okay, so let me go ahead and get out of your way, and let's start by opening up a fresh new Linux terminal. And there's a couple of things that we need to do before we jump in and start coding. And that is, this lesson will make a lot more sense and be a lot easier if we are working with the same set of images. And so I've put together a GitHub repository that will allow you to download the same images that I am doing. So in order to do that, let's come over here. Let's just go to your home directory, change directory home. Okay, you should in your home directory have a PyPro folder if you have been following along with me. And you can get there by doing change directory downloads like that. And then if you look at ls, no, not downloads, change directory change directory. From your home directory, it should be desktop, and then an ls, and you can see there you should have a PyPro folder. If you don't, go ahead and make one. And then we're going to change directories down into PyPro. Okay, and now we want to go out and get those demo images, and we can do that simply by typing git, G-I-T, and then clone. We're going to clone my repository, and it is https github.com/github.com/mcwhorpj, and then /demo images like that. So let's go ahead and try that. Oh, close. Close, but no clone. What was I thinking? Clone like that. Okay, it's cloning the images. It has found them. It is bringing them in. And boom, there it is. So now let's do an ls. You can see that we have a new folder now called demo images. Let's go down into that, change directory, demo images, and let's do an ls. And now you can see that I have known images and I have unknown images. If I look in the known images, change directory into known, you can look and do an ls, and you can see I have a lot of JPEG images of different specific known people. Okay, so that's going to be what we're going to be used for training. And then of course the unknown images are going to be images that we will use for testing our software out. I'll show you one thing that you kind of need to know now, that in our training data set, what you need to do is any image that you want to teach it who that person is, put that image into the known folder, and then make the file name of that image the person. So you see I have like Chuck space Schumer. I have Donald space Trump. So name your files with the person's name, and then we can keep track of everything. It's just a little way that I do things, and if you do things that way, then it will make it a lot easier. So if you want to train on new people of your own, put a picture of them. It needs to be a clear picture with one face and that person's face, and then put it into this folder. But I'm kind of getting ahead of myself here, so let me go ahead and start teaching you how to do the face recognition. So you need to come over and you need to open up Visual Studio Code, okay, and then what you're going to need to do is open up a fresh new program. I believe that we are working in a folder called Face Recognizer. Okay, if you don't have a folder called Face Recognizer, make one. And then inside of Face Recognizer, we are going to add a new file, and I'm going to call it Face Recognizer-1.py. Okay, and the .py is kind of important. And boom, there we are with a fresh new Python program, and we are ready to code. Okay, so what I'm going to show you is I'm going to show you how to train Python on a face, and then I'm going to show you how to recognize a face. But the first thing we're going to do is we're just going to see if we can find faces. We're going to look at a picture and see if we can find faces using Face Recognizer, because that's kind of like the first simple step, and it'll allow you to begin to get comfortable with the program. So if you're going to use face recognition, you need to import it. So we will say import face recognition, and notice there between face and recognition there is an underscore. So we're going to import face recognition. We are going to import CV2. And guys, I should say that I am on Jetpack 4.4. I've not done any fancy upgrades of Jetpack 4.4. I've just downloaded the Jetson Xavier NX Jetpack 4.4, and that's the one I'm operating on. And it would be good if we operate on the same one. So if you're watching this video later and you're like on Jetpack 4.8, no promises. This is for Jetpack 4.4. It would be good if we were operating on the same Jetpack. All right, so we're going to import CV2. Let's go ahead and print the CV2 dot underscore underscore version underscore underscore. There we go. Let's just run this and make sure that we can import face recognition that our library installs went right last week. So it is thinking. And it shows that we are on OpenCV version 4.1.1, and that is good. So we have our library, and we didn't get an error when we tried to import the face recognition. So that is all very good news. And so the first thing that we ought to do is let's just use the face recognition library to go out and load an image. And so in order to do that, we got to kind of figure out an image that we are going to load. And so let's just open up our File Explorer here, the little filing cabinet. Let's go to Desktop. Let's go to PyPro. Okay, and there are our demo images, and let's look at our unknown demo images just to see if we can find a good picture. And I kind of like that picture with these four guys here that is u1.jpg. So in order to load that in, let's get its path. We can do that by right mouse clicking and saying Properties. Then here under Parent Folder, click on that, right mouse click on it and say Select All, and then say Copy, and that will give us the path to that picture. And so we can come over here, and what we can do is we can say Image is equal to Face Recognition dot load underscore image underscore file. All right, now what file? We're going to put it in a single quote, and now I should be able to paste that path So I will say paste, and we go all the way down to unknown, and then I need to do slash the file name. What was the file name? The file name was u1.jpg. So I'll come over here, u1.jpg. Okay, so now that should load that picture into Face Recognizer. Now let's just see. I will need to close my parentheses here. I guess it's already closed it for me. I'll hit enter. So now let's just see if we can find faces in that picture. So I'm going to say face locations. We're not identifying faces now. We're just seeing if we can find faces. So face locations is going to be equal to face underscore recognition dot face underscore locations. And then what do we want to look at? We want to look at image. So this is going to take that picture that we loaded in. It's going to look at it, and it's going to see if it can find all of the faces. All right, and it's going to put that in the array face locations. That sounds pretty good. Now let's just print face locations, and that is going to be kind of like the upper left corner of the face and the lower right corner of the face, and it's going to be an array, and it's going to have upper left, lower right for each face that it finds. And so let's see if it finds anything here. So we are just going to run Python file in terminal, see if we get an error. Okay, it's on 4.4.1. All right, boom. That is really cool. Now look at this. It returned an array, and that array has found 4 faces. And you've got kind of upper left, lower right of the first face, upper right, lower left, or is it, let's see, upper left, lower right, I think. Upper left, lower right of the first face, the second face, the third face, and the fourth face. So it found 4 faces in that image. So let's go back and look at that. Let's see if I can go back to, where was that? Desktop. And then let's go into PyPro, and then let's go into demo images, and let's go into unknown, I believe we were, and then let's just click on this U1 and see if it will open it up. I thought I had a thing that would preview this. Okay, there it is. All right, and look at that. Very good. There's 1, 2, 3, 4 faces in the image, and it is giving me here, down here, the position of the 4 faces, and it boxes them, upper left and lower right. So we are making lots of good progress. All right, so now though, this is one thing, first thing that you've got to learn about facial recognition, the face recognition library, is it deals with an image in red, green, blue, but OpenCV wants to use blue, green, red. And so if we're going to play with this image in OpenCV, we're going to have to convert it. And so what I'm going to say is image is equal to cv2.cvt color, all right? And what am I going to convert? I'm going to convert image, my original image, and how am I going to convert it? Using cv2.color underscore, and where am I? I'm in RGB, and I want to go to what? BGR. So I take that image, that JPEG image, and I go from RGB to BGR, which is what OpenCV wants. So now my image has been converted into the right format, and now let's just sort of step through, right? Let's step through this array of positions, and let's draw a box around every face. So how can I do that? Well, I want to step through, so I'll say 4, and then what is this? This first number is going to be row 1 and then column 1, and then this is row 2 and column 2. And so this face recognizer thinks in terms of rows and columns, which is kind of like Y and X, but it's the row 1, column 1, and then row 2, column 2. Okay, and that'll be how the box is done. So I'm going to go 4, and what did I say? Well, it's going to be row 1 is the first number. Row 1 is the first number. Column 1. So row 1, column 1 is the upper left corner of my face, or of the face. And then what? Row 2, column 2. Okay, and that is in face locations. Okay, so when we did this face locations, is face recognition dot face locations of image, that returns that array of points here, here, and then here, here, and then here, here, and then here, here, one for each face in the pictures, and it goes row, column, row, column. All right, so this should then step through each one of these face locations, each one of these face locations. I hope that makes sense. All right. I'm being a little bit repetitive here because you really got to kind of understand how the data is coming at you. Now, what are we going to do? We're just going to draw a picture around each one. So I will do a CV2.rectangle. I want to draw the rectangle on what? On the image. And then, now this is kind of what's crazy. Face recognizer thinks in terms of row and column. So it's sort of like row, comma, column. But OpenCV thinks in terms of X, comma, Y. Well, X is the column and Y is the row. So you've got to kind of put these in the other order. And so you're going to go column 1 is the X value that OpenCV wants, and then row 1 is the Y value. So column 1 comma row 1 would give you X comma Y. And now you also need then the other corner of the box, which would be column 2 comma row 2. Now, if that doesn't make sense, pause and rewind and listen to it again. Now, what am I going to put? I'm going to put a box around it. What color do I want the box? Oh, how about blue, which would be 255, 0, 0, because it's blue, green, red. So blue would be big and the other would be turned off. And let's give that box a line width of 2. All right. Now what we need to do is just a little bit of cleanup, and so that's going to step through the positions and put a box on each face. And then what we need to do is show our image. So we'll do a cv2.im show. And what do we want to show? We're going to show it in my window. And then what are we going to show? We're going to show the image that we have been working with. Does that sound good? We're going to show the image. And then what we need to do is move that window to put it up in the corner. So we're going to say move window. And what window do we want to move? I want to move my window. And then what do I want to do? I want to move it to 0, 0, like that. So I'll put it in the upper left corner of my screen. And now we got to give a clean way to kill this. So I'll say if cv2 dot weight key, and I'll put a 0 in here, is equal to the ORD value of Q. So this if statement is just asking, was the Q key pressed? Was the Q key pressed? And if the Q key was pressed, then what we want to do is cv2.destroy all windows, and we're going to destroy all windows here, windows like that. Okay, cv2.destroy all windows if the Q is pressed. So that, I think, should be a good program. So what are we expecting? We're expecting it to load that picture. We're expecting it to find all the faces and then just draw a box around the face. Now, it's not going to try to figure out who they are. It's just going to try to figure out if there are people in the picture or not. So that looks pretty good. Let's go ahead and run this and see what happens. So we will right mouse click and run Python file in terminal. Looking good. Boom! Look at that. Okay. So can you see that? The picture pops up and it found all 4 faces, it identified them, and it put a box around them. How do we kill this? With the Q button. All right, boom. So where are we right now? We can load in a picture into the face recognition library. We can find all the faces, we can find where they are, and then we can draw a box around them. So that is pretty cool. And I'm going to go ahead and save this program. So I will say, hopefully, save. And now what do I want to do? Well, now I want to kind of learn how to not just find the faces, but figure out who is in the box, identify the people in the box. So to do that, let's go ahead and let's make a new program. So I will open up here again, and I will come to the face recognizer, and I will add a new program. Let's call it face recognizer -2.py. Okay, we have a fresh new program. And let's go ahead and let's cheat a little bit. Let's go back to 1. And I think that these first 3 lines we can just copy and come over here, load our libraries. We know that those things work, so we're just going to use that. Now, what we need to do is we need to train it on some known faces. I'm going to show you how to train it on 2 known faces. Now you can then train it on however many you want to, because if you can do it for 2, you can do it for however many. But let's come over here and let's look back in our known images. So I'm going to open the little filing cabinet. I'm going to go to desktop. I am going to go to PyPro. I'm going to go to demo images, and I'm going to go to known. Now there's a lot of known people in here, but I'm going to train it on Donald space Trump, and I am going to train it on Nancy space Pelosi. And since I am going to need to know the path to the pictures, I'm going to go ahead and right mouse click on Don. The path to Don and the path to Nancy will be the same. It's just the file name will be different. But I'm going to say properties, and then I'm going to come down here to parent folder. I'm going to say select all. I'm going to right mouse click and say copy. Okay. And now I'm going to come over here and I am going to load those 2 faces. So I'm going to say Don face is equal to, remember how to load a picture, face recognition dot load image file. So we're going to do a face recognition, face underscore recognition dot load underscore image underscore file. And now I've got to give it a path. I'm going to put an open quote, and then I'm going to pass that path. That gets me all the way down to the known folder, but now I got to give it a file name. Well, do you remember that was Donald, uppercase D, Donald space Trump dot JPG. Now that should load that image of Donald Trump. Now I'm going to hit enter. Now for Nancy's face, it should be almost the same. So I'm going to just copy that line of code. I'm going to paste it. But here, this is going to be, for a file name, path is the same, but the file name is Nancy space Pelosi. And then that should go into her file name. And so we will call this Nancy face. All right, so now I have Don face and I have Nancy face. Like that. All right. right? And now let's just go back and look and make sure that this makes sense, right? I have Donald space Trump .jpg. I have Nancy space Pelosi .jpg. So it should be able to load those two. Let's just run it and make sure that it's finding those. It's not going to do anything, but let's just make sure we don't get an error when we do this. Okay, boom. It went out. It loaded those two images. Well, what we want to do now is we want to learn those faces. And the way we learn the faces is we encode the faces, okay? And so when you're training, you've got to make sure that the picture that you're training on only has one face, okay? Or this whole thing falls apart. But on the training files, you want to just have one face in each one. Now, when we go in and start doing recognition, we can do a lot more, but on training, it's got to be real straightforward that you have one face in each picture, and the file name of that picture tells you who it is. So now what we want to do is we want to do the recognition. We want to learn that face. And so we need to encode the face. We need to learn it. We need to encode it. So I'm going to say Don encode is going to be equal to face underscore recognition dot face encodings. Okay, so what am I doing? I'm doing an encoding on that face, Don, on Don's face. I'm going to encode it. All right, and so what am I going to encode? Don face. All right, now you have to understand that this is looking for more than one face, so it's going to return an array of arrays, and so it's going to be kind of a bracket and then brackets inside of that. Even though it's just one, to get our parentheses to match, to get our brackets to match, we got to tell it to take the first one or the 0th element. Okay, and so we're going to tell it to take the 0th element. And even though there is just one, it will make the brackets match out right. And try it if you don't believe me. It won't work if you don't put that 0th element there. All right. So that will encode Don. And so now let's do Nancy. So we're going to take that and we are going to come to a new line. And now what we are going to do, we are going to, in the next line, do a Nancy encode, and there we are going to do face recognition dot face encodings, but instead of Don face we are going to do Nancy face. All right, Nancy face, and remember Nancy face was read in already. So now we have two encodings. All right. Now, if we're going to go in and look and match things, we need to create an array that has all of our training data in it. So I'm going to create an array of our known faces, and I'm going to call that array encodings. And I'm going to put in it everything that we know. Well, what do we know? We have, well, Don encode, and then what else do we have? Nancy encode. All right. Now, if you wanted to do all of these, you would need to read in Anthony Fauci's face, you would need to encode his face, and then you would need to add that to your encoding. So you would need to do that for each one of these different people. Okay, but I'm showing you for two. I am showing you for two. So I've got my encodings array. These are the people I know, and I've got in there Don encode and Nancy encode. Now I've got to tell it who those people are. So I'm going to say names, the names that go with those encodings, and you've got to put the names in the same order. You've got to put the names in the same order as the encodings. So the first name is going to be Donald space Trump. Notice that I'm doing it as a string inside of quotes. And then who is the second person? That would be Nancy Pelosi. All right. Like that. So I've got the encodings. That's the people I know. And then I've got their names. And the names are in the corresponding positions in the arrays with the encodings. Okay, that seems pretty good. All right, now we're going to be trying to find them in other pictures, and so we'll want to put some names on it. So let's go ahead and say font, is equal to cv2 dot font underscore Hershey, and I will do font underscore Hershey underscore simplex cv2 dot font underscore Hershey underscore simplex. And I am going to get that out of your way so you can see better. Okay, so font is font underscore Hershey underscore simplex. Okay, now I want to go to an unknown image and I want to see if I can recognize it. So I need to load that unknown image. So I'm going to say test image is equal to face underscore recognition dot load image file. But this time, instead of loading something to train on, I'm going to load something and try to figure out what it is. And so would I want a known image or an unknown image? Well, here I am going to want a unknown image, but I can still use that. Now let me go back and get the path, okay, because it's going to be slightly different. So I'm not going to be in the known folder. I'm going to be in the unknown folder. And let's just do this u3.jpg. I'm going to right mouse click on it, properties. I'm going to click on the parent folder here, right mouse click, select all. I'm going to say copy, and that is going to give me my path here. I will control V to paste, and then I'm going to put the file name, which was let me look again over here. It was u3.jpg was the file name. u3.jpg. So right here I will put u3.jpg. Okay, does that make sense? So I've got the path to it all the way down through the file name. So I now have an image, a test image, and I can see if I can do face recognition on it. I've got it loaded in. Well, I need to see if I can find the faces. So I will say face positions, kind of like before, is equal to face underscore recognition, okay, dot face underscore locations, like that. Okay, what do I want to look at? I want to look at test image, and then what do I want to do? So I've got basically the face positions. Let's see. I'm going to confuse you. I loaded the test image, and that was that picture with Donald Trump and Nancy Pelosi together. Now I need to find in that picture where the faces are. So face positions is going to be face recognition dot face locations. Okay, and then what am I going to look at? The picture test image that I just loaded. All right, now I need to go in and I need to find the encodings. I need to encode the images that were found. So face positions is where they are, but now I need to encode each one of them. So I'm going to say all encodings, and now I got to encode those things I just found is going to be face underscore recognition dot face underscore encodings. And what am I going to look at? Test image. And where am I going to look? In face positions. So I'm telling it to encode, looking at test image, each of the face positions. So I'm passing it the face positions that I just found. Face positions has the positions. Test image is the whole image. I'm telling it to encode each one of the face positions. So if there are two faces, there will be two face positions, and then I will create an encoding for each one of those, and those encodings will go into the array of all encodings. Now, I want to work with this in OpenCV, so I'm going to go ahead and convert my test image. So I'm going to say the test image is equal to cv2.cvt color. And then I'm going to look at test image, and then I'm going to convert it cv2 dot color, cv2 dot color. And where am I going to go? Well, it is in RGB, and I want to go to what? BGR. All right. Because remember, the face recognizer loads it as an RGB. OpenCV is going to want BGR. So now test image is in the right format for OpenCV. Okay, now let's see if we can go through that list of the encodings that it just found. All right, and so let me show you how to do that. So we're going to go 4, and we're going to step through the face positions, and the face positions were in what? Top left, or top, it's going to be top right and bottom left. Okay, top right and bottom left. So we're going to go through top, right, bottom, left, like that. And then also we're going to go through the face encodings, face encoding. So we're stepping through two things. We're stepping through the position of the box and the encoding of the face. And that's going to be in, and since I'm stepping through two things at the same time, I've got to use the zip. All right. And this one is going to be face positions, face position plural, because face positions is where we found all the face positions. So we're going to go face positions. And then also all encodings. So this is where all the faces are. This face, this face, this face, this face. And then this is the encoding, the encoding, the encoding that goes with the face. So we're stepping through two things. This is kind of a pretty fancy for loop here where we're going to step through both of those things. All right. Now, what we have to see is the first time through, it might find a face, but it might not recognize it. Well, we still need to put a name on that box, even if it's not recognized. So I need to just go ahead and give it a name. I'm going to say name is equal to unknown life form. Now, if it recognizes the person, it will give it a real name. But if it doesn't recognize the person, at least this variable name won't be empty. It will identify it as a person that it doesn't know. Okay, now what I need to do is I need to find matches. So matches is going to be equal to face recognition, face underscore recognition, and then what do I need to do? I need to compare underscore faces. And what am I going to compare? I'm going to compare all of my encodings. This is everyone that I know, right? Remember, this encodings is everyone that you know. These are the encodings of everyone that you know. That is my trained data set, the things that I know. So I am going to compare encodings. Let's see. Encodings, that's everyone I know, with what? The one that I am looking at right now, encoding singular. So face encoding is the one face that I'm considering right now, right? the face encoding the present face that I'm looking at, and I'm seeing if it matches any of the entire set of people I know. Okay, make sure that you understand that. If you don't, go back and rewind and think about it. So I'm looking for matches. Now, if there is a true, meaning if there is a match, if there is a true in matches, if there is a true in matches, I want to find the first match index, and that is going to be find matches dot index of true. Okay, so when I find matches, if the face that I'm looking at matches any of those encodings, it's going to make that position true. So if face encoding was Nancy Pelosi, then it is going to put this position, it's going to put this position to be true because it's a match. And this one would be false. But if it was a picture of Donald Trump, this position would have a true, this position would have a false. If it was someone that it didn't know, this one would be false, this one would be false, and it would never get in that if statement. But if there is a true anywhere in matches, then I want to find the first match index is where that true is. So this would come back in my case. If it was Donald Trump, it would come back with a 0. If it was Nancy Pelosi, it would come back with a 1. And if I had a long string of faces that I was looking through, it would kind of keep going. I hope that makes sense. So this is the index of the match. Well, what is the person's name? Well, the name would then just be, name would be equal to names of first match index. Because remember, names is all the names. And so if it was Don, matches would be 0, and names of 0 would be Donald Trump. If there was a match at Nancy, then this would be a 1, and then your names would then look at this position here, right? Stop, think about it, make sure that you understand that. But now I should have a name. Well, if it didn't find anyone, it would never get, if there were no matches, it wouldn't get in here, and name would remain unknown life form. Okay, so now that we should know who the people are, we can go in, we're still inside of the for loop, and we can just start boxing the faces. So we can say cv2.rectangle. And what do we want to put it on? Test image. And then we want to go from left comma top to right comma bottom. And I know this is really confusing, but what you've got to see is you've just got to understand that Face Recognizer goes on rows, columns, so it's row, comma, column, but OpenCV goes X, comma, Y, which is like comma, column, comma, row. And so you've got to kind of keep track of where you are. So here we're going to go left, because that's the X value, left, comma, top, and then right, comma, bottom. And I sure hope that makes sense. And now we got to give it a color for the box. And so let's just come in here and let's give it a color of blue. So we're going to say 255, comma, 0, comma, 0, a color of blue. And then let's give it a weight of the box of 2. All right. So that should be good. Okay, and let's just see if this thing will run before we do anything else. I'm going to come back to Face Recognizer 1 that we just did, and then I am going to do the CV2 IM show, the move window, and the quit out of it. So those last 4 lines of code from this program I will copy. and come over here and paste. And now it should run. It should put boxes around their face, but it's not going to put any label on it. I just want to make sure that nothing crashes. So it is loading. We'll have a sip of coffee. And what we're hoping is we're hoping that it doesn't crash. Oh my goodness. Oh, okay, image. We, in this program, are calling it test image. So we got to adjust the name of it. And I believe it was an uppercase I. So we're using a different file name from before. So let's try this again. Hoping for success. It is thinking. All right, boom. So you see, the nice thing is it found the faces, it boxed them, and it did the person recognition, the face recognition without crashing. We'll cue out of this. I think now all we need to do is just label the faces. Okay, I think at this point all we need to do is label the faces. And so I think that I probably missed. Okay, so that's that. And now I need to come here. And now what I need to do is put a label on it. Well, if I'm going to put a label on it, I want to put a background for the label so you can always read the label. So I'm going to put another rectangle, CV2, and this rectangle is just going to hold the label. And so it's going to be rectangle. And where do I want to put the rectangle? On test image. And then how big do I want it to be? Well, I want to go from, again, left, comma, top, and then I want to go comma, and then I want to go left plus 200, and then I want to go comma, top plus 30. And so that's just going to put in the upper left of my window, it's going to put a rectangle with a solid color that I can put my text on top of. So I'm going to go left plus 200, that's plenty of length for the text, and then top plus 30, that will be enough height for it. And then I need to give it a color. Well, let's give it a color of blue again, 255, 0, 0. The background will be blue. All right. And then let's make it a -1, which will make the box solid. Okay, that will make the box solid. And now I do believe we just need one more command, which is to put the name on the box. So we're going to do a CV2 dot put text. Where do we want to put it? We want to put it on test image. Right? We want to put it on test image. And then where do we want to put it? Well, we want to put it at the left position of the box. The left position of the box. And then we're going to go top plus 20, so that will bring it down. If I just put it at top, it would just be straddling that box. I want to put top plus 20, which will bring it down into the box. Okay. Then what do I want to put there? I guess before I do that, I want to put text image, and then what text do I want to put? Well, I want to put the name. Right? And if it doesn't have a name, it's going to say unknown life form or whatever. But if it does have a name, it will put the person's name if it found the person. Okay, so that looks good. And then I need to tell it what font to use. And I already defined my font. I'm going to make the font a height of 0.75. And then I am going to make it a color of... Let's see, what color do I want to make it? Let me make it blue, and don't panic. I'm going to say 255, 0, 0, and then a heaviness of 2. All right, so I have made the box blue, and I made the text blue. So what I'm going to do is I'm going to make the background, instead of blue, I'm going to make it yellow, which would be 0, 2, 255, comma 255. So the background is going to be yellow and the text is going to be blue, if I am thinking of this right. All right, so let's run this thing. Looking good so far. Boom! Look at that. Donald Trump and Nancy Pelosi. Okay, guys, so look at this is a huge step forward. So what you can see is now, if you want to recognize more people, what you have to do is for each additional person, like you have Don face and you loaded Don's image, Nancy face, you loaded Nancy's image. You can then just load all the people that you want to learn. And then after you do that, then what you have to do is, like you did a Don encode on Don face, a Nancy encode on Nancy face, well, you need to do a Mike encode of Mike's face and a Joe encode of Joe's face. So you can just load your images and then do your learnings. And then as you add more people, you have to put them in your encodings array, and then you have to add their name to the names array, and the encodings and the names need to be in the right order, in the same order. All right. Then what you do is you load an image of unknown people. All right. And then for that image of unknown people, you want to find all the faces. So you find the face locations, and then for each one of those face positions in your test image, you want to encode each face in that image, and then that will go into an array of encodings called all encodings. So it would like have the first person, the first faces encodings, the second faces encodings, the third faces encodings of all the faces that are in that picture. All right. Now what you're going to do is you are going to step through all of those faces in the picture by stepping through the face positions and that face positions encodings. Okay, you're going to step through both of those things. Now, you're going to start by just saying it's an unknown life form, just in case you don't find anybody you recognize, it will still name to put on them. Now what we're going to match is we are going to match the encodings. That was the training data from the very top. We're going to see if that matches, if those match any of the faces, the face encoding that we just found. Okay, so the specific face that we are on, we're going to see if it matches anybody in our known list. All right, if there is a match, we want to find what position matched. And then we find the index of the match, and then we find the name of that index, and then that is the person in that particular box. And then we just step through all the boxes. We step through all the people in that individual picture, and then we draw a box around their face. We label their face. All right, so that is how that works. So let's come in and let's look then at a different picture. And so let's come over here at a different known one, and let me see if anything. Let's do u11.jpg. Okay, let's run this on u11.jpg, and I think that will be interesting. So we will come over here, and our test image is going to be u11.jpg, and let's see what happens. It's thinking about it. It seems to be happy. Boom. Okay, now look at this. It found Donald Trump. It found Nancy Pelosi. It found Mike Pence, but it doesn't know who Mike Pence is. It says unknown life form. It doesn't recognize Mike Pence. Tell me what would be pretty cool to do at this point. How about we learn Mike Pence? Pence. Okay, so how would we do that? We would come up here and we would learn someone new. So let's take this load image line, Control C, and then Control V. Okay, but instead of Don face, Nancy face, this would be Mike face. And then let's see if we have a trained image. Let's see if we have a known image for him. So we go to Demo Images under Known. You can see that we've got Mike space Pence.jpg. So we are going to put that here, and it's in that known folder. So it's going to be Mike space Pence. I can't believe I don't know how to spell Mike Pence. Can you believe that? P-E-N-C-E. Okay. So I spelled that right. And Mike face. Now what I need to do is I need to encode his face. So I'll do Control C. Come down here. I will encode his face. And so this is Mike face. And then this then becomes Mike in code. All right. Now I have a third one, a third person I know, so I've got to add him to my whole encodings array. So I'll add Mike in code. And then I've got to add his name in the corresponding position. So I will add Mike Pence, like that. I think that's all we've done is now we're going to train it on a new person. And we'll run this. And it is thinking. Boom! Look at that. We've got Mike Pence, we have Nancy Pelosi, and we have Donald Trump. All right, guys, that is very exciting. So what you guys, your homework assignment for next week is to go ahead and kind of get comfortable with this. And so what I want you to do is I want you to train it on every one of these known images. So you're going to do Anthony Fauci, Bill Barr, Charlton Heston, go through. And so instead of having 1, 2, 3, you're going to have 1, 2, 3, 4, 5, 6, 12. You're going to have like 13 people that it recognizes. Okay, you're going to have 13 people that it recognizes. So then encodings is going to have 13, and then names is going to have 13 names, and then you can recognize a much broader range of people. Now, if you want to, you can go do people you're interested in. You can put people in your known folder that you're going to train on of like family members or things like that. Okay, does that make sense? But then just get comfortable with these data structures, because I tried to explain it as clearly as I could, but you've got to kind of understand what it is that I'm doing. Don't just copy what I'm doing, but spend enough time this week to really understand it. And then next week, what I'll do is I'll show you kind of a really clever solution to the homework problem of how to train on a lot of different faces. But your homework is to train on those 13 faces so that you could recognize them in pictures. Okay, guys, I have had a lot of fun with this. And this is really where the Jetson Xavier is going to shine, because this face recognition uses a whole lot of computation power. And so this is really going to be where we start benefiting from the Jetson Xavier NX, because it is really fast and we're running a computationally intensive calculation here to do these face recognitions. Okay, guys, have fun with the homework. If you like this lesson, be sure to give us a thumbs up. Share this with some other people. Again, really appreciate you guys that are helping me on Patreon. You're the guys that are fueling this whole operation. Okay, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.